Good afternoon. Welcome to our second section on Introduction to Algebra. Last week we did the basic definitions, sort of introducing vocabulary concerning some of the basic stuff we need for algebra. We stopped at the classification of algebraic expressions. We learned that we were able to classify algebraic expressions by the number of terms. That's one type of classification. We also learned how to classify them by the highest exponent, which is also known as the degree of the polynomial. Today, we're going to finish that off by classifying them jointly, because there's a way that you name the polynomials when you classify jointly. So I'm just going to quickly review these concepts and then we transition into substitution and evaluation. So here's the first expression right here, the first algebraic expression. So on this side, we have 6 algebraic expressions, and over here, we're going to write the classifications. That way, we're just basically reviewing the end of last week's session, and then we're going to transition into today's session. So the first item has 1, 2, 3 terms. 3 terms, and if we were to classify that by the number of terms, we would say it's a trinomial. 3 trinomial. That's what this would be. Now, by the degree, the highest exponent is, this is 0, this is 1, this is 2. So the highest exponent for that trinomial is 2. So therefore, it is quadratic. 2, highest exponent of 2 is a quadratic expression. So if we were to put the 2 classifications together, we say that it is a quadratic trinomial. Again, if you weren't in last week's class, then you're going to be a little confused for the first 5 minutes, 5-10 minutes. But after that, I'm going to introduce something brand new. But this is just a continuation of the introduction to algebra. The second term, or the second expression, has 2 terms. First, second. The highest exponent is a 4. There are only 2 terms, and if you have 2 terms, it's a binomial. 2 terms, like bicycle. Binomial, bilingual, 2 languages, bicycle, binomial, 2 terms. Now, the highest exponent is a 4, and we say that if it's 4, it is quartic. Quartic for degree 4. So this is a quartic. Binomial. Okay, now we go to the third one. The number of terms, 1, 2, 3, 4 terms. There are 4 terms, and based on our discussion we had, we said that if we have 4 or more, we call that a polynomial. So it's a polynomial. What is the degree? It is degree of 3. And if it is to the power 3, we say it's cubic. So this is a cubic polynomial. Cubic polynomial. Now this one is cute. Just 1 term only, and it's to the power 5. So if it is 1 term, it's a monomial, and if it's a power 5, it's called quintic. So it's a quintic monomial. Quintic monomial. Okay, now we go to these at the bottom. 1, 2, 3, 4, 5. So 5 terms, we said if you have 4 or more, we refer to them as, or to that expression as a polynomial. So let's go to the degree. The degree is 4, so it's a quartic polynomial. And finally, we have the degree of this one. Remember, the degree is the highest exponent. So what is the highest exponent? It is a 6. So we did not classify anything beyond 5. So we say that it's going to be a polynomial. And this is 1, 2, 3, 4, 5 terms. So it's more than, it's 4 or more. So it's a polynomial. And the degree is bigger than 5. So we're going to say it's a polynomial of degree 6. Polynomial of degree 6. Polynomial of degree 6. So that's it right there. You're now experts at classifying algebraic expressions. So we have the monomial, the binomial, the trinomial, and after 3, polynomial. And then for the classification by degree, we have the constant, which means that it's just a number without a variable. It's a constant. Then we have the linear, then we have binomial, linear, quadratic, cubic, quartic, quintic, and after 5, we say it's a polynomial of degree 7, 8, 6, whatever the number is. That is bigger than 5. So that's it for our classification. So we are now done with classification. Okay? Okay, so very common thing that is used in mathematics, in algebra, you hear the expression like terms. Like terms as compared to versus unlike. So what are like terms? Like terms are terms that have the same exponent. They have the same exponent, then they are considered like terms. If the exponents are different, then they are called unlike terms. What's the importance of that? Well, I'm glad you asked. We can only add or subtract algebraic expressions when we have like terms. So, for example, let me write it. If I give you say for example, 2x squared plus 5x plus 7 plus 3x plus 3. If we had this plus that, we say, okay, what is it equal to? All we have to do is to go through 2x squared. Is there a term with x squared over here? No, there's none. So therefore, it stays by itself. This is a 5x, the power is 1. 3x, the power is 1. So these two are like terms. So therefore you can put them together. 5x plus 3x is 8x. And finally, 7 plus 3, 10. Okay, not complicated at all. Let's try another one. If we have So we have 5x cubed minus 2x squared plus 6 minus 2x cubed plus 4x squared plus 3x. What is that equal to? We say, okay, 5x cubed is a like term to 2x cubed, so we can do the subtraction. 5x cubed take away 2x cubed is 3x cubed. Minus 2x squared minus 4x squared. These two can be combined because they are the same degree. They can be combined. So we end up with minus 6x squared. What is next? Oh, 3x. There is no term with just x with a power of 1. So it's going to be minus 3x, nothing to combine it with. There is no common term. So we'll just put minus 3x. And finally, plus 6, there is no constant over here, so the 6 remains by itself. So it's just 6. All these terms are of different power. This is 3, 2, 1, 0. So therefore, they are unlike terms. You cannot combine them. Okay? So that's what it is when we talk about like terms and unlike terms. For them to be like terms, they have to have the same exponent. And they are unlike terms if they have different exponents. Now we're going to have some fun. I mentioned to you we're going to do evaluation. Okay? Yes. We're doing evaluation and substitution. If A is equal to 4, B is equal to 5, and C is equal to -2, find the value of 2A plus B minus 3C. So we want to evaluate what is this equal to. We're saying that A is the same as 4 in this example. B is the same as 5, and C is the same as -2. What is this expression equal to? And this is how we work this out. (2A plus B minus 3C is going to be obtained by plugging in 4 wherever I see A, 5 wherever I see B, and negative 2 wherever I see C. So here we go. It's 2 times 4 plus 5 minus 3 times C. What is C? Negative 2. Now, one of the first lessons we did way back a few weeks ago was working with negative and positive numbers and also order of operations. So those things now are going to come into play as we do these examples. So what's that equal to? Well, 2 times 4 is 8 plus 5. Notice this minus 3 has a multiplication right here. So we have to do the multiplication first before we can combine these two terms with the 5. Multiplication goes before subtraction. So it's going to be negative 3 times negative 2 gives me positive 6. So this question in particular works out to be 8 plus 5, 13, plus 6, 19. That will be the answer for that question. Okay? Let's try another one. Let's try a different question. Find the value of b squared minus 2 times okay? So given these values of A, B, and C, what would this be equal to? Well, let's check it out. B squared minus 2 times 3A minus 4B equal to, all I'm going to do is, wherever I see B, I plug in 4. Wherever I see A, I plug in, wherever I see B, I plug in 5. Wherever I see A, I plug in 4. Wherever I see C, oh, there's no C. Maybe just to make it, there's no C, I'll just go ahead and do it just like this. So B squared means 5 squared minus 2 times 3A. So 3A will be 3 times 4 minus 4 times B minus 4 times B, which is 5. And then we have to close the bracket over there. So what's that equal to? It's equal to 5 5s, 25. That's what this is, 25. Minus 2 times. I need to work out what's inside the parentheses first before I can multiply by the 2. So parentheses go first, and then we multiply afterwards. 3 4s, 12. Minus 4 times 5 is 20. So now it's 25 minus 2 times whatever I get here. So it's equal to 25 minus 2 times 12 minus 20 is negative 8. So that gives me 25. Negative 2 times negative 8 is 16. And that works out to be 41. See, step by step by step by step. Following the procedure, we plug in the right numbers. Notice there was no value for C in the expression, so therefore there's no, negative 2 is nowhere here. We didn't put in a C because C was not part of the question. Sometimes they will trick you by giving you more information than you need, and if you're not careful, you'll get caught in the trap. So be careful. Watch out for these traps. Okay? Good. One last one. Find the value of 4c cubed squared minus 2 times, let's use plus 2 times 3a minus 3b. Okay, let's try that. So 4c squared plus 2 times 3a minus 3b is equal to, let's plug in the numbers as given. So it's going to be 4 times, what is c? It's negative 2 squared. Plus, here's a plus, 2 times 3 times a. What is a? A is 4. Minus 3 times b. What is b? B is 5. Okay, so last week we did a lot of definitions, a lot of vocabulary. This week we're going to do some manipulations. We're going to do some different things this week. So what do we end up with? We have to work this out for negative 2 times negative 2. You give me 4. Negative times negative is positive. 2 times 2 is 4. So that gives me 4. We have to work out this first, and then we're going to multiply after. Plus 2 times 3 4s 12, 3 5s 15. Step by step. By the way, you notice I used a different level set of parentheses. We use a square bracket, just so you can differentiate between these two. And this is on the overall. This is on the outside, and on the inside we put the parentheses right there on the inside. So what do we end up with? 4 times 4 is 16, plus 2 times 12 minus 15 is negative 3. So what does that give us? 16 minus 6 gives me an answer of 10. Final answer is 10. Okay, can we see the 10? There's a 10 right there. Good. Okay. I'm going to show you a question that I saw Sunday. Somebody called me and told me that his son was working on a problem and he was stuck. I'm going to show you what the problem was. I'm going to show you really what the problem was, and you're going to be like, wow, look at this. If A star B is equal to 2A minus B, find Yes, somebody called me, a good friend of mine called me and said his son was working on this practice for an exam. And this was what the question was like. A star B is equal to 2A minus B. So the star function is being defined as double the first term and subtract the second. Whatever is here, double it, and then subtract the second term. That's it. But now they want to see what you do if you were given that. How do you approach it? And the real answer to the question is, you work this out, you work that out, and then you put these two together. That's the approach. You work the first part out, you work the second part out, and then you put the two answers together and get your final answer. So let's go. 2 asterisk 1 is equal to, according to the definition, it's 2 times the first number minus the second number. What is that equal to? 2 times 2 is 4, minus 1 is 3. So we end up with 3 for this part. What about the second part? This is 3 star 4. So let's think over here. 3 star 4 is equal to, whatever it is, you double the first and subtract the second. So it's 2 times 3 minus 4. So it's equal to 6 minus 4 equals to 2. So technically, this question boils down to 3, this is 3 star 2. So this becomes, we got 3 right here from this is 3, there it is, star, there it is, and this gave me 2, so there's a 2 right here. And what do we do if we got 3 star 2? It's going to be 2 times 3. That's the definition. 2 times the first number minus the second number. So that gives me 6 take away 2 equal to 4. So again, all that is involved here is substitution and then following the order of operation, substitution. Okay? And that's how you work on that question right there. So now we're going to go into another section. Just so you know, on Thursday, I plan to solve equations in algebra. So we're building up to that point, okay? So for now, I want to go into what is called function notation and composite. Function notation and composite functions, okay? And the best way to teach this is by using examples. That's the best way to do this. So, okay, here we go. If f of x is equal to 2x minus 7 and g of x is equal to 12 minus x squared. Find the first thing I want to find is, what is f of 5? Here's what you do. You're being told that f is a function of the variable x, or f of anything is the same as double what is here, double what's in the parentheses, and subtract 7. So when I give you f of 5, you need to double 5 and subtract 7. That's all it is. G of anything is equal to 12 minus whatever is here squared. Whatever is here to the power 2. Plug it in, simplify. That's it. So this case, f of 5 must be equal to 2 times 5 minus 7. And that's going to give me 10 minus 7. So f of 5 is the same as 3. That's it. That's it. Let's try another one. You might see a question like this. Fine, this is number 2. Oh, that's not good. Okay, number 2. They might say to you, okay, what is G of -3 plus F of yes. What about that one? Find G of -3 plus F of 2. Again, substitution. Plug in for X wherever you see, put -3 wherever you see X, put 2 wherever you see X for this function, evaluate, get your answer. So here we go. For the G of -3 is going to be equal to 12 minus -3, put it in parentheses, squared. It is X squared. What is X? X is what is in the parentheses. Whatever is in the parentheses, square it. And there's a subtraction sign in front of it. But you know that from the order of operation, you have to do the power 2 first. The power goes first. The exponent goes before you do subtraction. So what do we end up with? It's going to be 12 minus -3 times -3 is 9. So this is actually equal to 3. So G of -3 is +3. So what about F of 2? F of 2 is going to be equal to 2 times 2 minus 7. So that's equal to 4 minus 7 equal to -3. And what did they ask us to do? They asked us to find G of -3, which is this, plus F of this, which is that. So what's going to be the answer? The answer is going to be this part, which is 3, plus this part, which is -3. And what is 3 plus -3? 3 positives, 3 negatives, they cancel. The answer is 0. Okay, so let's go over this again. F is defined as this. G is defined as that. In this example, I could define it any way I want. I just chose to define as given. And I wanted to evaluate G of -3 plus F of 2. So I work this out separate, I work that out separate, and then I add the two results together, and that's it. Let's try another one, number 3. Okay, what about G of F of wow, that's ugly. So we need to find G of F of 1. So how do you do it? We have to find out what is this equal to. Find what this is equal to first, so you work from the inside out. Whatever this is equal to, and then plug that into the G function, and then get your answer. So let's go. Let's find what F of 1 is. F of 1, F of anything, double it, subtract 7. So it's 2 times 1 minus 7. It's 2 minus 7 equal to -5. So that's what this is equal to. This is the same as -5. So I'm going to write this equal to G of, I just found out this to be -5. And now I need to evaluate G of -5. You'll be amazed to know how many people have problems with functions. But with functions, you just have to be patient and go step by step by step, and it works itself out beautifully. So what do we end up with? G of -5 is defined as 12 minus -5 to the power 2. So it's 12 minus -5 squared. So it's equal to 12 minus -5 squared is positive 25. And 12 take away 25 gives me -13. So this expression actually works out to be equal to -13. Let's try another one. Number 4. So it's G of 4. Same process. You find what this is equal to, plug it into this. So here we go. G of 4 is equal to 12 minus 4 squared. It's equal to 12 minus 16 equal to -4. That's what the inside is equal to, -4. So now I have to find G of -4. And what is that equal to? Go back to the function. It's 12 minus -4 squared. You notice because it's a negative, I put it in parentheses. When it was positive, I didn't have to put it in parentheses. But because it's negative, I have to put it in parentheses so you know that it's a negative times a negative. Otherwise, you'll make a mistake. Okay? What does that give us? It's 12 minus -4 squared is positive 16. So the final answer is -4. Notice it's coincidental that the final answer is the same as what we have here. It doesn't always work like that. Okay? Good. Okay, how about this one? Let's do one that's really, really messy. How about this? This is number 5. How about f of g of f of 0? Wow, wow, crazy, crazy. So again, we have to work from the inside out. So I'm going to find f of 0, then I plug it into g, then find g of that result, then I plug it into f. So we start from the inside and we work our way out, step by step. F of 0, whatever I get, g of that number, whatever I get, f of that number. And that's my final answer. So let's go. F of 0 is equal to 2 times 0 minus 7. 2 times 0 is 0, minus 7 is -7. So we just found out that f of 0 is -7. So the problem now becomes f of g of -7. So it has 3 layers. We did the first layer, so now we have 2 layers to go. So what is g of -7? G of -7 is equal to 12 minus -7 squared. So it's going to be equal to 12 minus, what is -7 squared? 49. So 12 minus 49 equals to -32. 7. So G of negative 7 is negative 37. So I now need to plug negative 37 to represent all of what's inside. So this becomes F of negative 37. Let's back up and see what we did. First thing we did, we found F of 0, we got negative 7. So we replaced the F of 0, we put negative 7. So now we need to find G of negative 7. We did that, we got negative 37. So now we replace the G of negative 37, negative 7 when we wrote it as negative 37. We need to find F of that final result, and we're good to go. And what is F of negative 37? It's going to be equal to 2 times negative 37 minus 7 equal to negative 74 minus 7 equal to negative 81. So this ugly expression here eventually simplified to be equal to negative 81. How cool is that? Pretty cool. You'll be amazed to know how many people get puzzled when they see these things. It's like, whoa, what do you do? And my response is, take it one step at a time. If you're served a plate of food, you don't take the entire plate and gulp it down. You take one serving at a time. One serving at a time until you finish the process. Okay? So, notice I said function notations and the composite functions. I never use the word composite yet, but I'm going to show it to you right now. So let's call that number 6. So number 6. If you saw F composite G of X, it is F with a little o, like the degree symbol, it's raised up. So it's F with a little 0, G, is the F composite G of X. It is red. F composite G of X is a composite function of F and G, composite function. And all it means is you find G of X, and whatever you get, you find F of that result. So it's actually the same as F of G of X. It's the same thing as that. Notice, we worked on this just now. We were working on that, but it's for you to know that when you see this, that's what it means. A lot of people do not know that. You see the O, there's the little O, which means composite, and they didn't know that it's equal to this. It's F of G of X. That's what it is. Okay? Now that is not the same as G composite F of X. If you saw this, this is not the same as this. Notice the G goes first and the F comes after. Then when you do the operation, you have to go G of F of X. I said something just now that might be misunderstood. I said if the G is written first, it's not the same as when the F is written first. That's what I meant. So if the G is written first, it's a different process than if the F is written first. If the G is written first, then it means that that function is going to be done last. Why? Because we work from the inside out. From the inside out. So G composite F of X means G of F of X. Okay? So that's what that is about. So we go from whatever is closest to the x goes first, and then we do the second function afterwards. Okay? And now I'm going to finish this section by showing you how this would become really complicated very fast. I'll show you using number 7. Yeah. Once I give you numbers, it's very easy to work with. But if I start to give you letters, some people get nervous and get confused very fast. So we're saying that f of anything is equal to 2 times whatever it is minus 7. G of anything, x is just symbolic of whatever, is equal to 12 minus whatever is here squared to the power 2. So suppose you were asked, what is f of suppose you were asked what is that equal to? F of 3y plus 4. What does it mean? Well, check it out. Let's go back to the definition. F of anything is equal to double whatever is here in the parentheses and then subtract 7. What is in our parentheses here? 3y plus 4. So when you do the actual definition, it means that you have to double this, and whatever you get, you subtract 7. So it is equal to 2 times whatever is in the parentheses, which is 3y plus 4, and then minus 7. So that's equal to 2 times 3y is 6y, 2 times 4 is 8, minus 7. Notice that 2 only multiplied times what is in the parentheses. That's all that you double. And then when you simplify this, 6y plus 8 minus 7 gives you 6y minus 1. So this is equal to 6y minus 1. This is the part that gives a lot of students difficulty. A lot of students have difficulty with this part because it becomes abstract once you put another letter in there. They say, whoa, what's going on? That gets them nervous very fast. Okay? Let me show you another one. This is number 8. So if I ask you what is g of 2x? Uh-oh, now I've lost my mind. G of x is equal to that. What is g of 2x? Remember, g of anything is equal to 12 minus that thing squared. So I don't care what is put in the parentheses. That's the template. That's the pattern you follow. And you just take your time and apply it to the T, you will get the right answer. So g of whatever is going to be equal to 12 minus whatever squared. All I've done, I've followed the pattern. That's the pattern, that's the template. I went exactly as how it is defined. G of anything is equal to 12 minus anything squared. So g of 2x is going to be equal to 12 minus 2x squared. And what is that? It's equal to 12 minus 2x times 2x is 4. And that would be the answer for that. How cool is that? Now, here we go now to the composite. Watch this. We're going to do the composite with something that's abstract, not with numbers, but with letters. So number 9. If I ask you what is f composite G of x? You have f of x by itself, you have g of x by itself. What happens if I want the composite function? What is that going to be equal to? Well, it's equal to f of g of x. Remember, I said to you that the composite function means you perform this, and once you're finished with this, then you apply f to the result. So it's f of g of x. So what is g of x? So g of x is the same as 12 minus x squared. That is what g of x is. So how do I find f of anything? Oh, I double it and subtract 7. I double whatever is in my parentheses, double it, and then minus 7. So f of this, I must therefore double this and then subtract 7. So it's going to be equal to 2 times 12 minus x squared minus 7. There's a minus 7 right here. So it's equal to 24 minus 2x squared minus 7. When I do the subtraction, I end up with 17 minus 2x squared. That's what the composite function is equal to. So let me draw a line right here. And let's try g of g composite f of x. Let's see if I could squeeze this right in this corner right here. Let's see if we could get this done. So this is equal to g of f of x. So it's g of, what is f of x? F of x is 2x minus 7. So I need to replace this by 2x minus 7. And now how do I work this out? It's going to be 12 minus all of this squared. So it's going to be equal to 12 minus whatever is in the parentheses to the power 2. So this is what this is equal to. This is what this is equal to. Night and day, completely different. Of course, you could expand this and then combine like terms, but I just wanted to give you the point so you can see the difference and it becomes a little bit more abstract. Okay? So, there it is. We have done classifying by both the number of terms and the degree, classifying algebraic expressions using both standards, both methods of classification. We have done evaluation by substitution. We have done function notation, and then we have done the composite function with abstract input. And that is what I plan for you to do today. Come next class, which is on Thursday, I plan to start solving algebraic equations. So we're going to start with simple equations, and then we're going to transition up into quadratic equations and maybe cubic equations. Okay? So we're starting to build a little bit now. We're moving off the local lanes and moving on to quicker, moving at 45 miles an hour. We started at 25 miles an hour, and I think we're at 30, moving up into 40 mile zone, 40 mile an hour zone. Stay with me, okay? And we plan eventually to have sessions that we can have interaction, questions and answers. But so far, so good. This was the foundation I wanted to lay today, okay? And maybe I should just call it even right there. Or would you like to do one more? One more? Okay, let's do one more. Okay, one more. So, number 10. What is F composite G of 3x. Okay, what about that? Okay, so if we're given this, really, again, we're using these definitions. We're using these definitions. Another day, I could give you a different definition for x. For f, and a different definition for g, and I could give you another function h. I can give you whatever I want, okay? So, this is going to be equal to f of g of 3x. I just need to work out what g of 3x is. G of 3x is going to be 12 minus whatever is in the parentheses squared. So it's g 3x squared. So since I'm using parentheses inside of parentheses, I like to change. So you have two different levels. We call that the hierarchy. Different levels. We use the parentheses, square brackets, and then curly brackets. These are the curly brackets. So we use parentheses, square brackets, and then so we go from here to here, and then from here to here. So when you have parentheses inside parentheses, it's nice to differentiate by using different types of parentheses. That's all. Is it required? No, not required. It's just easier to read. Okay? And then we come here. What do we end up with? It's f of 12 minus, when we square this, we get 9x squared. And then we ask ourselves the question, what is f of anything? Well, f of anything is obtained by doubling it, doubling what's in the parentheses, and subtracting 7. So this is going to be equal to 2 times what is in the parentheses minus 7. And what does that simplify to give us? 2 times 12 is 24 minus 18x squared minus 7. And then 24 minus 7 happens to be 17 minus 18x squared. So that's our final answer. 17 minus 18x squared. So that's what this simple thing looking here works out to be. That's what it works out to be. Okay, so that's it for today. On behalf of the Brosis Foundation, we thank you for spending this time with us, and we hope that this triggered some intellectual energy, and I hope I didn't lose you. Just watch over from the beginning, especially going back to the previous tutorial and coming into this one. You will see that it all ties together nicely. Come Thursday, we'll start solving equations. We'll start simple, and then we'll end up with systems of equations. Until then, take good care of yourself. Thank you so much.